Hi, algebra students. Today we're going to be learning about simplifying radical expressions. Just like the exponents, there are some rules that you have with radicals, and we'll be learning about those today and in the next video. What is a radical expression? It looks like this, where there looks like a square root and a variable under, and there are some vocabulary words. This root is a radical. It is a square root. If you don't see anything there, they call it a square root. You can have cube roots and third roots, but we're only going to be talking about square roots right now. Underneath the square root, anything under there is called a radicand. So the vocabulary when we're doing this, those are the two words we'll use. What does a radical expression look like in simplest form? If you have a simplest radical, no radicands can have a perfect square factor other than 1. No radicands can contain fractions. No radicals can appear in the denominator of a fraction. Today we'll be dealing with mainly the first one, with simplifying radicals. So how do you do that? Well, what we do, one way, is to make a factor tree. So we're looking for perfect squares to come out, because a perfect square can come out from underneath a radical. So when I take this 80 and I break it down into its factors, 10 times 8, that's one way to break it down into two things that multiply to give you 80. Now 8 also breaks down. 8 breaks down into, or factors into, 2 times 4. And 10 factors into 5 times 2. Now I'm looking for everything at the bottom of my factor tree to be a prime number. 5 is a prime number. 2 is a prime number. 2 is a prime number. 4 is not a prime number. So I have another number that I can break into its factors. So now I have 2 is a prime number and 2 is a prime number. So I have 1, 2, 3, 4, 5 prime numbers that multiply together to give me 80. So you're trying to break your value into a factor tree that has prime numbers on its ends. Now you're going to circle the pairs of numbers. So okay, I have a pair of 2's. I have another pair of 2's. Remember, you can only circle those prime numbers at the end. And then I have this one single 5 that does not have a partner. So once you circle those pairs, they will be taken out of your radical as a single value. For example, if I had underneath a square root 4, that would be 2 times 2. So if I had a pair of 2's, it would come out as a single value, because the square root of 4 is only 1, 2. So a pair comes out as a single. So I have a pair of 2's, that'll come out as a single 2. I have another pair of 2's, that'll come out as a single 2. And then I have this 5. Anything that is left that does not have a pair stays under or inside the radical. And then the last step is just to clean it up. 2 times 2 is 4, radical 5. So let's do that factor tree one more time. 54. And again, it doesn't matter how you break down the original. I'm going to do 9 times 6. It's just at the very end, you will always have the same prime numbers as someone who broke it down a different way. 9 breaks down into 3 times 3, and 6 breaks down into 3 times 2. Again, I'm looking for pairs of numbers. I have a pair of 3's. I know to stop because all of these were prime numbers. A pair of 3's is a pair, but then I look and this 3 doesn't have another pair and this 2 does not have another pair. So this pair of 3's comes out as a single. And these two that do not have partners, they stay underneath. They do not have another pair to come out. And then the last thing you do again is to simplify. Again, the reason why a pair comes out as a single was because if you have the square root of 2 times 2, you're looking for what number squared makes 4? 2. Squared makes 4. So the square root of 4 was 2. So any pair that you have comes out as a single. So we'll do 180. 180 breaks down into many different things, but I'm just going to do 18 times 10. 18 breaks down into 9 times 2. 2 is prime, so I stop with the 2, but the 9 can continue to break down into 3 and 3. And now those are prime. I look all the way over here. I have 10. 10 still can be broken down into 2 times 5. that is prime, and that is prime. So once I have all my prime numbers at the end of my tree, I can start circling pairs. I have a pair of 3s that's going to come out as a single 3. And I also have a pair of 2s. They don't have to be right next to each other, as long as they're in that factor area. So a pair of 2s that comes out as a single 2. Now I don't write 32, I write 3 times 2. And then I have this 5 that did not have a partner. He cannot come out and play. He's got to stay home under the root, so that is a 5 under there. And then you simplify by cleaning up anything. 3 times 2 on the outside is 6. I'm going to try these. Try to stay ahead. 64 breaks down into 8 times 8. Breaks down into 4 times 2. 2 times 4, 2 times 2, 2 times 2, and now I have all of my primes at the very end. Make sure you get them all, and when you circle, you'll notice this pair of 2s comes out as a single 2, this pair of 2s comes out as a single 2, this pair of 2s comes out as a single 2, and there's no other primes at the bottom of my tree that have not been circled. So this 2 comes out, this 2 comes out, and this 2 comes out. And 2 times 2 is 4, times 2 is 8. Wait a minute, I should have noticed that at the very beginning. The square root of 64 is 8. We'll do 24. Again, try to stay ahead. It doesn't matter how you break down the original, as long as you have all primes at the bottom of your tree. So 6 breaks down into 3 times 2, those are prime. 4 breaks down into 2 times 2, those are prime. So even if you broke this up a different way, if you broke this into 2 and 12, you would still end up having the 2, and the 12 would break down into 3 times 4, and then the 4 would break down it. So you have the same primes at the end. Go looking for your pairs. I have a pair of 2s. This 3 does not have another pair at the end of the prime factor tree, and the 2 doesn't have another pair. So the 2s come out as a single 2, and these guys don't have anyone to come out and play with a pair, so they stay home. And then you just clean it up. 3 times 2 is 6. 420. Try that one out. I'm going to break it up into 42 times 10. 42 is 2 times 21. 21 is 3 times 7. 10 is 2 times 5, and let me check to make sure that I've broken them all up into their primes. A lot of times what I'll do also, if it's a bigger number like that, I'll take 5 times 2 times 7 times 3 times 2 and make sure it is in fact 420. Now when I circle my pairs, they don't have to be next to each other. So you see this 2 over here and this 2 over here, they're going to come out as a single 2. Then I have a 3, a 7, and a 5, but none of those have a partner. So the 3, the 7, and the 5, 3, the 7, and the 5 are all underneath the square root. So when you clean that up, it's 2 square root 21 times 5 is 105. 2 square root 105. All right, 30. Again, if you want to pause and try them on your own. 30, I'm going to do as 3 times 10. 3 is prime. 10 is 2 times, uh-oh. That's prime, that's prime, that's prime. None of them have a partner, so I'm back where I started. If none of them have a partner, they all stay home, and I write it out. So this already cannot be simplified. So this cannot be simplified, so you're just rewriting it as its original value. All right, go ahead and try letter H and letter I. So we broke it down, and we should have a pair of 3s. Comes out as a single 3, and the 5 stays home. Go ahead and try letter I. And you have a pair of 7s. Comes out as a single 7. And this 5 that did not have a partner stays home. So that is simplifying radicals. But just like many other situations, when you have radicals, you also have some radical rules. So the first rule is the product property, and it states that if you have two square roots multiplied to each other, then you can take their product and write them underneath a single root. So square root of 2 times the square root of 14 can be written as the square root of 28. And now I'm back where I was on the problem on the page before, where I have to break them down. 7 times 4, and 4 is 2 times 2. So what I have is a pair of 2's. So those will come out as a single 2, and the 7 doesn't have a partner, he stays home. So remember to get all the way down to your prime factors. So again, we're going to use the product rule here. The product rule says if you have a product of 2 square roots, you can write that product underneath the same square root. 5 times 10 is 50, and then you simplify like you did on the last page. I'm going to break that down into 5 and 10. 5 is prime, so I stay there. 10 is 5 and 2, and now both of those are prime. And then I have a pair of 5's. So a pair of 5's comes out as a single 5, and then this 2 does not have a partner, so see, he stays home. Again, keep going with the next couple. 6 times 8, underneath the same square root. Break it into its prime factors. Again, it doesn't matter what your original prime factors are. It's going to break down into the same thing. Ooh, very small over there. And so 2, 2, 2, 2, and 3. Again, when it's a bigger number like that, I like to multiply it back together just to make sure that I have all the values. So I have a pair of 2's right here going to come out as a single 2. I have a pair of 2's right here going to come out as a single 2. And then I have this 3 who does not have a partner, so he's going to stay home. Pair of 2's comes out as a single 2. Pair of 2's comes out as a single 2. Those multiply together to give you 4, radical 3. Try the next 3 problems on your own. Okay, so now we have the 54. When you multiply them together, you broke it all the way down, and you had 3, 3, 3, and 2. So it gives you a pair of 3's. And then the 3 and the 2 do not have partners, so your answer is 3 square root. And I could write them separately, but I'm just going to cut a little bit of a corner here, and just I know that they're going to be multiplied together. The next one, you have a pair of 2's, another pair of 2's, and then your single 3. So a pair of 2's comes out as a single 2, pair of 2's comes out as a single 2, and this 3 stays home. Again, I could have cut that corner and just went and wrote 4 to begin with. Now this last one, when I multiply it together, I get a square root of 100. So I can do what I did on the last page where I broke it all the way down, or I can recognize that 100 is a perfect square. What number times itself will give you 100? 10. 10 times 10 will give you 100. And if you think about it, you can circle the pair of 10's and they come out as a single 10. For the next sets of problems, we have a combination where you have numbers outside and numbers underneath. So if you use the community property, you can just write this as 3 times 4 times radical 10 times radical 10. So I can move those around, and 3 times 4 is 12. 10 times 10 is 100. So this 100 will simplify as 10. And this 12 that is already out there, I now have 12 times the square root of 100. So 12 times the square root of 100 is 10. So that makes 120. The next one you have, again, if you used rearranging that, you don't have to do that every time. You can just know that the numbers that are out get multiplied together, so that's 40, and the numbers that are under the square roots get multiplied together, and that's 36. Oh, again, I have the square root of 36, which is 6. So 40 times the square root of 36 means 40 times 6, which is 240. You're not always going to be that fortunate. Sometimes it's not going to be a nice whole number answer. For example, here I have a 1 out front. So 1 times 2 is 2. 8 times a square root of 8 times the square root of 11 is the square root of 88. And a square root of 88 is not a perfect square, so I am going to need to break this down. 88 is 8 times 11, 2 times 4, 2 times 2. So I have 2 as a prime number, 2 is a prime number, 2, and 11 are my prime numbers. Looking for pairs, I have a pair of 2's. So that's going to come out as a 2. And then under the square root, I have a 2 and an 11, so that's 22. And as I noticed, I made a mistake. I have simplified the square root of square root of 88, of 2 times 22. But what I forgot was that I had this 2 out front to begin with. So this 2 that's out front to begin with has to still stay there. So my final answer will be 4 square root 22. It's such a common mistake, even I just made it. Make sure that you notice those that are out front. In order to avoid that, I will usually, so I'll write the 4 times the 2, the 3 times the 2 is 6, the 8 times the 7, and then I'll go ahead and break this down. 5 times 6, well, I'll break it back up into 8 times 7. 8 is 4 times 2, 2 times 2. And so what happens is, under the square roots, I end up with a pair of 2's, and then this 2 and this 7 will stay underneath. But don't forget, you had this 6 out front to begin with. The 6 that you had out front stays out front, and now when I simplify, I bring out the 2, and then the 2 and the 7 stay underneath. So that's 12 square root 14. All right, so the next thing we have is, I'm going to put it on pause. You're going to try these next two yourself. For the next problem, I had the 4 out front. The 8 times 2 became 16. Here, square root of 16. 16 is a perfect square, so the square root of 16 is 4. 4 times 4 is 16. Don't forget about that 14 that's out front. When you simplify the square root of 50, you get 5 radical 2. Don't forget the 14 that's out front. That'll end up with 70 square root of 2. The last section that we have is when we are dealing with variables. So to simplify variables in a radical expression, you're going to represent the variables with exponents in terms of repeated multiplication. Now I'll show you the long way first, and then I'll show you the short way. So if we have underneath the square root, we have 45. And we have A times A times A times A times B, 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 C, 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 C. So that's what we have underneath the square root. We know how to simplify the square root of 45. I'm going to do it over here. The square root of 45 is 9 times 5. 9 is 3 times 3. So we have a pair of 3's. So that answer is going to be 3 square root 5. But as far as the variables, we are again going to look for pairs. So I have a pair of A's. I have another pair of A's. I have a pair of B's. I have another pair of B's. I have a pair of C's, another one, and another one. The only one that didn't have a partner was this B right here. So just as I did with the variable, or the values, the constants, when you simplify, you look for a pair and it comes out as a single. And then that will stay under the root. Same thing with the variables. When I have a pair, it comes out. I have an A. A pair of A's comes out as another A. A pair of B's comes out as a B. A pair of B's comes out as another B. A pair of C's, another one, and another one. And what's left under the square root? I have this 5, and I have this B. So then I'm going to rewrite that as 3a squared b squared c cubed, or to the third power, square root 5b. And that is your answer. You can write it where you have repeated multiplication, or you can write it as even powers. So this even power, a to the fourth, came out as a squared. This even power of c to the sixth came out as c to the third. So you have 3 pairs of c's. Because you had 6 to begin with, you had 3 pairs. So you're basically dividing that by 2. Now, since this one was odd, you're going to have 1 left over. So b to the fourth times b under the root. If you thought of it like that, then b to the fourth came out as b squared, and you had a b left over. So there are shortcuts here. We're going to rewrite it out the long way for a few problems. So again, we have 32, and if I were to do 32 off to the side here, the square root of 32 is 2 times 16, 2 times 8, 2 times 4, 2 times 2. So I have a pair of 2's, another pair of 2's, and 1 2 left over. So I'm going to deal with the variables. Again, if I rewrite them as R, R, 4 S's, and 5 T's, I can do the same thing where I circle a pair of R's, a pair of S's, another pair of S's, a pair of T's, another pair of T's, and 1 T left over. So we have a pair of 2's, comes out as a 2. We have a pair of 2's, comes out as a 2. We have a pair of R's, comes out as an R. A pair of S's, another pair of S's, a pair of T's, another pair of T's, and what do I have left over? Underneath the square root, I have this constant of 2 and this variable of t. And so now I'm just going to simplify 4 r s squared t squared, and the 2 and the t stay underneath. And that is your answer. All right, next problem I want you guys to try on your own. Okay, so we took the 90 and simplified that. I have a pair of 3's, so it comes out as a single 3. The 2 and the 5, neither one of those have a partner, so they're going to stay under, so I'll take care of that in a second. I have a pair of X's, 2 pairs of Y's, 2 pairs of Z's, and you have an X and a Z left over, and a 2 and a 5 left over. So underneath the square root, 2 times 5 times X times Z. Simplify it, you get 3x y squared z squared. Underneath the square root, you have 10xz. Try the next 3 problems on your own. So if you rewrote this all out, your answer should have been 2y to the 5th z squared 14xz. But let's try it instead of rewriting everything out. Let's try it with the even powers on variables. So the 56 I took care of out here, but if I rewrote the variables, so they only had even powers. Now this first one, I don't have an option. I can't write it as an even power. It's x to the first. Y has an even power. Z to the 5th is not an even power, but I can write it as z to the 4th and z. So what happens is the 56 becomes 2 square root of 14, 2 square root of 14. The x is an odd power, so he's going to stay underneath. The y to the 10th is an even power, so you take half. The z to the 4th is an even power, so you take half. And this single z, anytime you have anything to the first power, it'll stay underneath. So let's try that one with the second problem. 24 breaks down into 6 times 4, 3 times 2, 2 times 2. So I have a pair of 2's right here. This 3 and this 2 don't go anywhere. If I rewrite the 7 as an even power, x to the 6th and x to the 6th and x to the 1st is x to the 7th. If I write y to the 9th as y to the 8th, and then y to the 1st power, there's always going to be that 1 left over. So my final answer, I have a pair of 2's, comes out as a single 2. I'm going to take care of this 2 and this 3 in just a second. I have these variables, so x to the 6th comes out as x to the 3rd. This is going to stay underneath. Y to the 8th comes out as y to the 4th. And this y to the 1st is going to stay underneath. So again, underneath, the 2 came out, the 2 and the 3 are underneath. You have this x stays under, and this y stays under. So that's a shortcut method. You don't have to do it like that. You can go ahead and rewrite it all out like you did before. But now I have this 3 out front, so don't forget about him. When you get all the way down to the answer, simplifying this, you'll have that 3 out front. So 25, square root of 25 is 5. P squared comes out as t, and the s stays under. But don't forget, you have that 3 out there. I'll write it up here. So your final answer will be 15 t square root s. Try to make your s's and your 5's look a little different. All right, we have 3 final questions. So this again, we have 7 square root 63 m to the 3rd p to the 2nd. So the square root of 63, do that off to the side. It breaks down into 3 times 3, so I have a pair of 3's. I have a 7 left over. This m to the 3rd I can write as m squared and m and p squared. So a pair of 3's comes out. M squared comes out as an m. P squared comes out as a p. I have a 7 left underneath. I have an m left. And so that's your final answer. Oh, no, it's not your final answer. I do it all the time. You got to remember that number that's out in front. So 21 MP square root of 7m. So then we have variables and numbers underneath, so they just get multiplied underneath. 20, 2 times 10. A to the 1st and a to the 5th is a to the 6th. B to the 2nd and b is b to the 3rd. And then you can go ahead and simplify that and also try letter I. So we have a pair of 2's, comes out as a single 2. A to the 6th comes out as a to the 3rd. B to the 2nd comes out as b. And you have the 5 and the b left underneath. Try letter I. So once you multiply everything underneath the same radical, product of radicals, so I can multiply everything underneath the same square root. I broke the 32 down into 2 times 2 times 2 times 2 times 2. I have a pair of 2's right here, another pair of 2's right here, and then a single 2 left over. I have c to the 6th is going to come out as c to the 3rd, d to the 4th is going to come out as d to the 2nd. So my final answer is 2. Well, one of my answers. I have another 2. C to the 6th comes out as c to the 3rd. D to the 4th comes out as d squared. And I have this 2 that's left underneath. So now my final answer is 4. C to the 3rd, d squared, square root of 2.